going to take a look at taking the derivative of log with a different base and the derivative of a number raised to the power of x. So the derivative of log to the base a of x. So whether it's 2, 10, doesn't matter. Alright, so first step you need to do is change the base of the log function to natural logs. And if you remember how to do this, we did this earlier in preparation of calculus, so I'm just going to go back there and show you just in case you forgot. It's the log of the regular number over the log of the base, basically. Alright, so we're going to transfer that to, it's whatever base you want, so we're going to make it natural log of m over natural log of b. Alright, then after that, you just follow the steps from taking the derivative of natural logs from our previous notes. This is a listening check. Underline 2. Underline the number 2. Alright, so let's take a look at an example. Let's say we had example 1, y equals log the base 2 for x squared. Alright, so first thing is we need to change the base. So it's log, well, first I'm going to make u, I'm going to say let u equal that thing so I can make it easier for me to explain it. Alright, so now we have y equals log to the base 2 of regular u. Alright, so now I can change the base. So I can say log of to the base 2 of u is the same as saying natural log of u over natural log of the base, which is 2. It's exactly the same thing because I now know how to take the derivative of that. So derivative of log to use one of the u, and log 2 is just a number. I'm just going to show you. If you put it in the calculator, you get a number. So it's just a number. So it's going to be 1 over u log 2. 1 over u log 2. And I'm just going to show you the numbers. So let's say we had log of u over 3, that's the same as 1/3 times log of u, which the derivative of that is 1/3 times 1 over u, which would be 1 over 3u. So it's exactly the same thing. So instead of 3, we have log of 2. Alright, so that's going to be 1 over u log 2. Taking the derivative of y with respect to u. Then we take the derivative of u with respect to x. It's going to get 8x. Alright, then go ahead and multiply them together. Do dy dx, dy du times du dx, so that those du's cancel. So we're going to have 1 over, replace the u with what it is, 4x squared times log of 2 times 8x. Alright, let's simplify that a little bit. We're going to get dy dx equals, the x's are going to cross out, and then 8 and 4 simplifies to 2 over x log of 2. And that's pretty much it. So the biggest thing here is just changing the base so that it looks exactly like what we did in the previous video. Alright, so let's take a more complicated question. Alright, so same thing. We're going to let u equals the whole thing. So negative 5x cubed minus 2 to the third power. So that means y is equal to log to the base 5 of u. That's good. Over here, we're going to let v equals everything but the power. So we're going to have u equals v to the third power. It just makes it easier. Alright, so first thing is we need to change the base. So changing the base is going to give us natural log of u. So natural log of u over natural log of the base. So natural log of u over natural log of the base. Alright, taking the derivative of that, I'm going to get 1 over u times log 5. Alright, taking this with respect to v, I'm going to get 3v squared. Taking this with respect to x, I'm going to get negative 15x squared, and then negative 2 is going to be 0. So dy dx equals dy du, and then du has to be on top, du dv, then dv has to be on top, dv dx. Alright, because all those cancel to leave dy dx. So then I have 1 over u, and I replace u with what u is. U is that whole thing, cubed, and then log 5 times du dv, which is 3 times whatever v is, put it in, squared, times dv dx, which is just negative 15x squared. Alright, let's simplify that a little bit. We can see that those powers are going to cancel out, just leaving 1 on the bottom. That whole thing goes away. Then I'm going to get dy dx is 3 times negative 15 is negative 45x squared, all over negative 5x squared minus 2 times log 5. And that's pretty much it. So the biggest thing is just change the base and then take natural logs like you had before. Alright, same thing with the derivative of a to x. Alright, so it's very, very important to know this. Take the log of both sides. You should have done this previously, so I'm just going to catch you up real quick. Take log of both sides, that's what I get. Use the property of log to rewrite that. So I don't know if you remember this, so I'm just going to show you to you real quick. So it's in preparation, it's one of the properties. It says that You just bring the power down. So log y x log of a, just bring the power down. Alright, once you've rewritten that, take e of both sides and solve for y. Take e of both sides, solve for y. And it's just important to know that e is the inverse of natural log. So e is the inverse of natural log. So I'm going to get y equals e, and the same thing as in the inverse of multiplication is division to both sides. That's what you're doing here. So you're going to get y equals e to the whole thing. Now we can say that since we got y equals, they're the same thing. So a to the x equals e x to the log a. It's a different way of writing it, so you need to remember this. Either remember it or learn how to get here. I don't remember it, I remember how to do this. So I'm going to do a couple examples the long way, and then if you remember this, you can do it the short way. Alright, and then after you do that, take the derivatives I've shown before when you were taking derivatives e to the x. So the same exact thing. So now we take the derivative, and this will give us a general format that will work every time. So a to the x is the same thing as e x to the log a. Alright, so let u equals the power, as we've normally been doing. So y equals e to the u. Alright, so then dy with respect to u is e to the u. And then du with respect to x, remember log a is just a number, so it's just going to be equal to that number, which is log of a. Alright, so dy dx is equal to dy du times du dy, so dx, sorry, so it can cancel out. So we're going to get e to the u and replace u with what it is, so x log a times log of a. Now we can replace e to the x log a back with ax, because it's the same thing, so it's ax log a. Okay, you need to memorize the derivative of a to the x is a to the x log a. This is a listening check, color and shortcut. I'm going to do it the long way for a couple of problems just so we can make sure that we understand how to do it the long way. So, example 2, take logs of both sides. Alright, bring the power down by properties, so x log x. And then take e of both sides, in other words, solve for y. So y equals e to the x log x. And then take the derivative as normal. So e to the x log x is the same thing as x to the x, basically. Alright, so we're going to have y equals e to the x log x. And then we're going to replace the power with u, so let u equal x log x. So we're going to have y equals e to the u. And then dy du is going to be e to the u. And then du dx is going to be, the product rule says, okay, derivative of that times that, so log x. Derivative of log x is 1 over x times the other one, which is x. So that simplifies to du dx is equal to log x plus the x is cancelled, given 1. Alright, so dy dx is dy du times du dx. And that's going to be e to the u and replace u back. So e to the x log x times log x plus 1. Alright, so remember e to the x log x is the same exact thing as x to the x. So we're going to put that back. X to the x times log x plus 1 in parentheses. This is a listening check, color in example 3. I want to show you the shortcut. So the shortcut says that you take a to the x, so in this case 3 to the x, times log of a, which is log of 3. And that's it, that's the answer. But I'm going to show you the long way, because should you forget, you should know how to do it. So take log of both sides like we've been doing. Bring the x down using properties. Solve for y, so taking e to the both sides. And remember, that's the exact same thing as 3 to the x. Alright, now take the derivative of that so that u equal the whole power. So now we have y equals e to the u, dy du is e to the u. And then du dx is just log 3, because remember, log 3 is a number. Alright, so then dy dx is equal to dy du times du dx. So that's equal to e to the u and put the u back. So e to the x, log 3, sorry, times log 3. And remember, that whole thing is the same as 3 to the x, log 3. And that's pretty much the same answer if you see. The shortcut or the long way gets to the exact same answer. It's just that the shortcut you have to remember it. Okay, so you have to commit it to memory. Alright, let's take a look at one more example. This time I'll just do the shortcut, just because I'm going to make it a little bit more complicated. Is equal to 4x cubed. So what does that leave? 8 to the u. So the derivative of that, remember, is the same thing. So 8 to the u times log of the 8. So du dx is equal to 12x squared. Alright, so dy dx is equal to dy du times du dx. So that cancels, leaving the right answer. So we h the u, put the u back, times du dx, which is 12x squared. And that doesn't simplify to anything, so that's just my answer. And that's pretty much it. I'm just going to separate my page because it looks like all over the place just because I made it try and fit. So I'm going to kind of split the page up so that when I look back on my notes I can follow through with what's happening, basically, because it looks like everything is all over the place. Drawing arrows to let me know what I was doing at that point. And that's pretty much it. So let's practice.